Alright, draft physics video. Probably going to move the camera around a bit. So sorry for the handheld thing, but that's the way it's going to have to be. Reading comments over there. Anyway, so yes, comments. Not really on the subject, but kind of interesting. I mean, the subject of the two last videos, Michelson, Morley, and the two slit experiments. And now we're back to the more fundamental argument about magnetism and gravity and the idea of the field tons and the interaction between electrons and protons and protons and electrons. Yes. Combs law. Alright, one part of it. So anyway, mindless. So I'll read some of this and then I'll have to draw a picture, I suppose. Just some quick things about Combs law, particularly at the time codes. I mean, really, realistically, first off, I don't read the comments on the individual videos, so I can't just click the time code because it won't take me to the right video. And even if I did, I don't think I'm going to do that. So I mean, unless your comments to somebody else who's got lots of free time, I think it's just better to quote somebody, and then you can put the time code in just in case they want to, blah blah blah. But anyway, you go back to the how many field lines hit the thing argument. But in this context, the number of interactions matter. Well, again, the context here is you're saying Combs law applies to single electrons as well as infinite planes. My argument is that it doesn't, that it really has to do with collections of electrons. It's the rules of what an incredibly large number of electrons do on surfaces, not what individual electrons, how they function. It's not a law about individual electrons, it's a law about charge on surfaces. That's the context. If you have a charged sphere or plane, the square inverse law comes from considering all the lines that radiate from the sphere. So you could think of that as one of those little drawings of a sun and little lines go out. Hence you divide the force by 4. Well, there's no hence to that. You have to explain that as you move closer, you intersect more and more lines. So, if I actually draw a little sphere with lines coming out, you can sort of understand that if you're this big and you're that far away, you only intersect 2 lines. But as you get closer, your size will get bigger relative to these lines, and then at that distance it'll be 4 lines. See? That's the inverse square. It's this cone that's sort of important. It's the angle, theta. And that can be arbitrary, but I'm just saying that's what it's meant by the field lines. They're not real lines. They're lines identifying the force as a quantity represented by 10 lines, 400 lines, 5,000 lines, 10 million lines. It doesn't matter. It's a proportional argument. As you get closer, you'll intersect more lines. That's inverse square. And those lines are created by individual electrons shooting straight rays. So the whole point I was making is the electron shoots one ray of force, so to speak. The electron, as it interacts with another electron, it's not doing the same thing. It's not creating an infinite number of lines of force. That's another way to put that. Electrons are really small. Quanta is really small. Electrons interact big, but their size is very small, so they can't radiate in a wide arc. Let's see how else to say it. It just doesn't matter. The point is the electron on electron relationship, the size never changes. The 2 electrons always have the same size, and the quanta between them is always the same size. So there's no the surface is getting bigger relative to the radiating light bulb kind of thing. That effect doesn't take place. It's the distance argument. From their perspective, the distance is irrelevant because there is no distance difference, because the quanta are even further away, so to speak. You can't, oh, no. Anyway, read on. The point is, Coulomb's law doesn't apply to electrons individually. Alright, hence you divide the force by 4, but one could naively say the distance is twice as long, so the bits have twice as long to move, and you have to divide by another factor of 2. So that's just a game you're playing. I mean, one could naively, as you stated, because the lines are already implying the distance. So time has already been factored into the fact that there's less force at that location. Again, the lines are arbitrary. They're not something necessarily real. They're real in the case of a surface with 1 trillion electrons on it, emanating force at different vectors. In that sense, it's real, but it's also real in the sense that the only thing that makes those lines or rays relevant is the fact that they're moving at the speed of light. That's the only way you could have the same force, proportional force. The force wouldn't be proportional if they weren't all moving at the same speed. Okay, anyway. Each field line needs to have twice as many bits upon doubling the distance. No, it doesn't. Not to have the simple 1 over r instead of 1 over r squared rule. Time is part of the distance no matter what you do. It's a proportional relationship. Twice the distance is proportionally twice the time. So it's the same. I don't see any problem there. You don't get to add anything. It's already accounted for when you either, if you use either time or distance to describe something bouncing back and forth, either one quantizes it. You don't get to use both. Alright. In other words, the density of the bits between the two bodies matters, and it is not clear at all how this plays out. Well, again, the density is affected by distance, and density of impacts would be affected by time. Time is a constant. You're only changing one of the variables, which is distance. So therefore, you only get to use the variable once. The other variable is fixed. Alright. When a black ton hits black electron, does the ton always get reflected at 180 degrees? I mean, who was talking about a... Alright, so he's saying, does it always get reflected? It's probably a word for a perfect reflection. Is it always a perfect reflection? Yes. Are there other degrees possible also? Stupid question, but might as rather ask that. Might as rather ask that. Well, anyway, I would suppose, yes, there's in the kinetic argument being made, you'd have to account for differences in energy, in a sense, if you didn't have perfect reflections. They would imply less momentum, or unquantized momentum. Not having to use the whole numbers. You sort of have to use the whole point of quantum mechanics was basically, the underlying point is that everything has to go into these Planck constants, and you can't have those. You don't have a half of one, no half a photon. Alright, so now he has some edited bit here. Let's see. Now, it's going to be a seemingly stupid question, but how do the bits get trapped between electrons? So it's a question. I mean, this is an incredibly arduous task I have here, as I've tried to explain before. I mean, their physics, they've had 100 years to engineer all kinds of explanations for why there's certain rules and why this does that. And a ton of their explanations don't have any explanation, like converting matter into bent space, for example, or dark matter, or so many of it. No explanation for the creation of the virtual photon that creates a magneton or a graviton. They just use this terminology. And anyway, so I'm just saying, even though they've had 100 years to fix it, they haven't even been able to fix their theory. And they've had, you could argue, millions of brains contemplating it. This theory has one brain and just a year. Some aspects of this are only a year old. And you want me to provide you explanations in a depth, not only that they don't even touch, in terms of giving you an explanation that isn't just fairy stuff, that's the rule, do the math, something like that. No theory, no model. So yeah, I mean, it's an okay question, but in a way, you know, in the context of you berating me with this obligation to debunk every claim in a scientific journal, it just seems like it might occur to you that your standards are double. That they're really not, you're not playing fair. So anyway, you don't do this to your physics. You don't ask them for these answers. Why are you asking me for these answers? I mean, these complex answers, like how did the universe get created? Anyway, so, all right, it doesn't hurt though. I mean, what the hell? I'll answer the question. I mean, thinking about it, something did occur to me. Okay, how did the bits get trapped between the electrons? So what if the Big Bang? If you thought of, like I said, the electrons are infinitesimally small. Let's say you had a shell, and it was made out of this black and red, proton and electron. And let's say some part of it gooified, fell apart. And so the outer shell was electron and proton, and those outer shells expanded, blew out, because the little bits broke free from them and became free flyers. And in that free flying, they're only reflecting off their own kind, so to speak. So the black stuff hits the electrons, bounces off, goes the opposite way, hits another electron, bounces off, goes the other way. So the density of the electrons is, you know, when they're packed, you know, 1 inch could be 10,000 light years of electrons at normal spacing, at our spacing. So anyway, something like that could be true. So their density is so thick that there's no way for the little bits to ever not finally hit an electron. They just can't shoot through space without hitting one. So it's like me saying I could shoot a photon into the deep space, and I would argue the probability is it won't get to 13 billion years away without hitting an electron first. You know, I mean, probabilistic, that 50% or 80% chance that that photon's not going to make it. It won't complete the journey. That's why we have to look so hard to see stuff, maybe. But clearly a lot of light does get to us, so there can't be too many electrons in the way, or we wouldn't get any light from 13 billion years ago away. All right. But there's just so, the density of it is so, you know, when you just even start thinking about how many photons are produced by a galaxy, you know, 13 billion light years away, it's a preposterous number of photons, you know, when you start thinking about it. You know, creating images in all kinds of locations. I don't really need a summary now, thank you. Okay. Sorry, it's a little bit hot as hell in here. Which is good. I mean, you know, it's been a kind of a moderately cool summer. So, but yes, it's a little hot for videos. Anyway, alright, so where does this question? Alright, I ask this because not only does the density of the bits between electrons matter, because the density of tons outside the electrons matters also. So I guess what I would argue is that if you thought about the idea of a Big Bang and the heavier bits were on the outside, the electrons and the protons, and they got blown to the end of the universe, they're like a bubble that everything bounces off of eventually. So if you go far enough, you'll finally hit the more densely arranged electrons at the end of the universe, where there's less pressure moving them, and so they're not moving much. You know, so there's not too much stuff getting to them, and we're still in the active place where stuff is bouncing back and forth. But anyway, it sort of just explains a universe that leaks its energy slowly rather than one that leaks its energy immediately. So it sort of does give you the idea of the pressure being great, and then it diminishes over time as it expands. So I think it's a viable way of understanding how the tons got between the electrons, is that's where they started, was between them. The Big Bang was the heavy bits on the outside, the liquid bits on the inside. The little bits are the ones that broke free, and they're the ones that pushed the bigger bits, and they pushed the bigger bits at variable speeds, which means the electrons and the protons mixed as they were pushed, but they had to be pushed by reflections. So you can sort of understand it's just like the same as the electron argument on electron, in the sense that if you start off with something bouncing back and forth in this small area, and then you expand the area, yeah, there's less impacts, but the stuff still isn't escaping. It's still hitting the stuff, and it's still reflecting. So it's not going anywhere, and it's creating a pressure. So that's the argument. It's the inverse of the beginning was the opposite of what is now. In the sense that now the pressure's on the outside. In the beginning, the pressure was on the inside. Alright. Because not only does the density of the bits between the electrons matter, but the density of tons outside the electrons matters also. Right, so I would argue that maybe at the end of the universe you lack any of that pressure, and everything just grinds to a halt. Alright, outside the electrons matters also. In order to produce an outward force, you need more pressure between the electrons than the pressure that pushes them together. Right. Now, understanding that the pressure is understood to be something that's going to equalize between the electrons. So, you know, we can't model this in our own heads. You know, we can't, you know, I can't, you know, I could draw a picture of electrons, and I could say, okay, well, this electron has six things bouncing back and forth, and this one has 10 things, and this one has 40, but they're further apart. And then you have to figure out all that, what that equals in terms of the amount of pressure in each direction going this way, and then the pressure coming in this way. So I'm just saying that what theoretically has happened over the long age of the universe, right, billions of years, billions of light years, is that all the electrons are always seeking neutrality. So they're seeking a relationship that is tending not to push them in any direction. So clearly all these things the 6 bits at 10 inches has to be the same as like 4 bits at 6 inches. In a sense, there's always an equalization taking place. So it's like my argument for acceleration. Acceleration takes a while to impose velocity because it has to spread the force and it has to move everything. The stuff not going the right way, so to speak. But electrons are always looking for that neutrality in the local field that is able to get to them, that's tangible to them. So I think that sort of addresses what you're talking about. So over time, I guess what I'm saying then is the external pressure in the big universe would already have neutralized, would already have had a long head start in terms of adjusting distances. And that, yes, you can break the rule just like with entropy, in closed systems. But the general rule is an even spread, and the universe has that sort of appearance of kind of an even spread of matter. All right. Electrons. You could argue that the places where it looks like there isn't an even spread might just be because the stuff in that location isn't on fire, or that it exploded. Anyway, it's about balancing pressures. Right. I can only use finitely many words, sadly, so let me point to this scenario. Take 2 giant negatively charged balls. They are repulsed because there is more density of blacktons between them. See, if it's between them, they're not going to be repulsed. Well, yes, right, you're right, repulsed. Okay. Between them, then the density of those pushing inward. Well, see, you have to understand that the black ones are only part of the equation, because every time a red one hits, it does move the object. It just doesn't reflect. It does the perpendicular thing. So it still is a force imposer. So the reds still impose a force. They just don't, you just can't trap reds. An electron can't trap a red, where it traps the blacks, which means they'll keep coming back. They're permanent. They're perpetual energy in a sense. Okay, the ones that are trapped end up being a kind of perpetual energy. The ones that are shot out in some other direction obviously may not hit something for 13 billion years and therefore weren't going to be relevant. But the one they reflected, often may have been ejected by something in the local field, and it's going to keep going back and forth, and so it's going to keep hitting it. The bullet will be reused. If the bullet's the same color, it'll keep coming back at you, whether you like it or not. It'll go back to the guy who shot it and come out the gun again. It's an infinite bullet, way to put it, where if it's a red bullet, it goes through and you're done. You're done probabilistically, and if it does come back, it's going to be coming back from another direction, which is going to push you in some other direction. It's not going to be pressure this way. It's going to be pressure some other way. It's converted into pressure from a different vector. All right. Anyway. All right. Scenario. Okay, they are repulsed because there is more density pushing inward. Now take one of the balls and move it to the side. So that's the whole point about when a photon is released. So the argument I'm making is photons are released by that very mechanism. So there's 2 electrons. There's bullets trapped, perpetually going back and forth. The electron moves because of some something comes in this way, let's say, and it wobbles this way or that way. But anyway, it opens an opportunity and tons at a frequency leave. The reflection is revealed in the frequency of the released tons. They end up being in phase because of the contraction. And so their release points become the same. Alright, now, what argument am I going to make here? Okay, so that's the whole point I'm making, is that that's when a photon is released. The photon doesn't come out of the electron. The photon is a byproduct of the relationship between two electrons. So in a sense, you have to have two electrons to create a photon, I would almost argue. Because it's that pressure that creates the frequency of the quanta leaving. Alright. Right, so it's the force again. So again, the argument isn't that the electron has any force. The electron has nothing except what the force gives it. The electron only moves if there's fish pushing it. So if the fish stop pushing, it doesn't move anymore. So it only goes where the pressure of the tons push it. And as soon as they stop pushing, it stops. It has no momentum. It can't maintain inertia, except its default state. I don't know how to say it. It doesn't maintain velocity. It can't hold force. Force has to keep acting on it for it to act as if it has force. It only has force while force is pushing it. That's enough to say. Alright. Now take one of the balls and move to the side. Why should there be some number of tons between them previously? Why should there be the same number of tons between them as previously? There wouldn't necessarily be. That's the whole point. That's why photons are released. And that's why energy in the system is lost, because you lost ton. You lost quanta. And new quanta has to come in to replace it. Something has to be pushed into the system to allow that gap to be filled. Which means there has to be another available electron, let's say, that's feeling pressure to go in but couldn't get in because the electron was in the way. Now the electron's out of the way, that other electron can take its spot, and now it's got the musical chair seat. So they're all playing like musical chairs. And whoever just slips into the slot, he's got the slot. And now the other guy can't go back. So now he's the free sucker. Yeah, I think that's perfectly reasonable. I think you're smart enough to understand that. Anyway, all right. About the paper, I couldn't find the link to the actual PDF. So this is about the article where the headline was, I'll read it. I think I still have the link here. A silly exaggeration. No, that's not it. Direct measure, here it is. Yeah. Come on, load already. Alright, science, direct measurement of light waves. You can't directly measure a light wave. So the sentence is, it is imprecise physics. It's almost an insult to physics to say it like that. Because it insults the word direct and measurement. It makes a buffoon of both those words to say that you're directly measuring light waves. Because you can't do that. You can only measure them indirectly by how they affect an electron. And that's it. There's nothing new here. Alright, anyway. So I don't know if I want to get into that whole crap. Well, I'll read it. What the hell. Alright, so the link's gone, but remember that I actually read most of the paper. What the paper did do was send 2 pulses of light that were carefully timed. The first one was a short high-frequency pulse that was supposed to knock the electrons out of the neon atoms. The second pulse was much longer, infrared pulse. Yes, well, as I've just pointed out, as I have pointed out previously, the effect of a force is dependent on timing. Timing is everything. How fast you shoot bullets at a cement pedestal that you want to knock over, at what frequency you shoot them, will decide whether you knock it over or not. Just a fact. It matters. Timing. Alright, frequency, the longer pulse. The point was that there was a screen on the side to detect the electrons. Detect which electron? The electron that was knocked out of the slot? The one that took its place? Again, they don't know the difference. Got this stupid fly in the house. Oh, that one's not doing too well anymore. Yeah, sorry, but you know, you land on my finger. You're kind of making it obvious. Kill me, kill me. Yeah, okay. The point was that there was a screen. To understand, the fly was going to die anyway, so I did it a favor. The point was that there was a screen on the side to detect the electrons on the side. Okay, so detect the electrons. Depending on how you timed the short pulse, the electrons went to one side or the other in unison. So again, that argument would be that's just back to my argument about the fact that electrons are affected. This is how they lose their velocity, by the energy that comes in from the sides. So any imbalance I have going forward, say this is forward, okay. Any imbalance I have going forward, and then I've been hit and I got more stuff going this way than I have going that way. The stuff coming in from the 2 other dimensions will, by probabilistic outcome, hit more of the things going this way than that way, because there's more things going that way than this way. And as they probabilistically hit more of them, they will convert those to going perpendicular. So they will eradicate any imbalances over time. The density of the random field will overcome any imbalance in a dimensional direction for the electron. Yeah, the fly isn't quite dead. Jesus. Obnoxious little bastard. Anyway, he's quite dead now. Gotta remember not to stick this pen in my mouth. Anyway, this is so nasty. I hate this place. Anyway. Alright, in unison. Okay, so that argument would be that would always be dependent on distance and the circumstances of the electrons in the atomic structure, and every atom has those arrangements. So obviously, if it's the same distance, they would tend to be going left, right, left, right. There's no reason to think that it wouldn't be dictated by the structure of the atom. The atom has other electrons in it, and those electrons are going to mean that there's more stuff coming from one side than the other in different locations. So depending on how far away you are, you'll encounter more pressure going one way than you would the other way. So it won't be random anymore. I mean, you can't really talk about a random field in a circumstance where you have a whole bunch of atomic structure, because that structure is going to completely own the field. It's going to define the field, and it's not going to be random anymore. Alright, in unison. Now, not only that, well, like I said, I don't think that is much, but whether they moved to one side or the other was consistently dependent on the timing of the pulse. So again, we're just back to a phase argument, or a distance argument, a two-slit argument even. Yes, it'll make a difference how far away you are, at what angle, how much field energy there is coming from one place or another. And I'm just saying that, so what? That's I don't know if I can draw pictures. I mean, if I take a hexagon and put it next to a square, you could sort of get the idea that the relationship between the force is there's going to be very funky lines of force that'll be created by that circumstance. So obviously, whether you go left or right will be dependent on the distance you are from any one of these surfaces. But they're all going to have a different pattern to some extent. But again, if they're all neon atoms, there's going to be a certain consistency in the pattern. Alright. In other words, consistently depend on the timing of the pulses. So even if you say that it is no problem that the electrons are supposed to move in groups, I'm going to argue that I don't think they move on as a group by any stretch, in the sense of it's all balancing their reflective forces. So they can't help but be affected by how each one of them moves when they're in a density. So whenever they're in a density, when one moves right, there might be one going somewhere left, but I'm just saying clearly there's a pattern. And the fact that magnets have positive and negative poles and all of this other stuff, I mean, I could just argue that it could be just the domain argument, that all matter has some polarization, and it wouldn't require it to have much polarization for there to be this on-off, north-south, north-south, north-south. Every atom could be, in some sense, not electrically perfectly neutral. There, fixed. I mean, that automatically creates a digital on-off, right-left potential. Anyway, suppose in groups, it is still the case that whether they go right or left, or how strongly they go right or left, depends on the timing of the pulses. And again, it also depends on how you're going to collect the electrons. I mean, how you measure an electron, what's your theory? It has to be moving. It has to have force pushing it for you to measure it. You can't see it if it's completely neutral. You just can't. You have to affect it with some other electron that affects some other electron. So again, you have to almost cause a chain reaction to even see one electron. You have to cause a chain reaction to make it visible in the first place. So again, this argument that you took a videotape of electrons doing this, that didn't happen. You took a movie of patterns left in atomic structure by the moving electron. The evidence is a long way from direct, and you have to account for how that matter affected the electron that you're watching. The act of measuring, again, is suspect in your results. Okay, you've got to be careful about what you're concluding in terms of separating the effect you're studying versus the effect of your measurement. Alright. Supposed to move in groups, right or left, depends on the timing of the pulses. So again, who would argue that the timing of the pulses wouldn't be significant in terms of mixing with the field energy of the atomic structure? So again, the field energy of the structure, the charge, is digital. You send another digital signal in, say, this way, obviously there's going to be phases of difference affecting each other when they mix. There's going to be stuff on phase and stuff off phase. Alright. Now you mentioned that your theory can expect the movement of electrons to influence other electrons. I'm not aware of those details. Well, how could you not be aware of those details if you understand how the force between every electron, it's reflecting bullets back to a guy who's shooting them. So how can you not understand that that would affect every other place that's also shooting at him in terms of the pressure argument? That if one thing moves closer and shoots more, that's going to change the pressure to move in a direction that's going to affect whether the other guy's bullets even hit him. Alright, anyway. Let's see, movement of electrons to influence other electrons. I'm not aware of those details, but even then, it still stands that the timing of the lights was what determines the outcome. And again, I'm not going to argue it. I mean, there's nothing in my theory that says frequency is not important. I've said it overtly, how frequency decides how what the effect of a quanta will be. We tend to call it something like more energetic, but the fact is it has nothing to do with having more energy. It just has to do with the electron being more sensitive to vibrations at that frequency, and at the tipping point it will tip. So I've made these arguments over and over. I said tipping point how many times in videos? And you're implying that somehow your contention that the phase, the frequency, that my theory somehow doesn't account for frequency being significant. That's nonsense. It's a nonsensical presumption or attitude for you to have when I have overtly said it so many times. I've used the term tipping point. Or tipping momentum, if you want me to. Maybe I have to say it in some other terminology. You don't understand rocking something? You know, I agree that we can't actually see photons or electrons, but we can gather data on certain aspects. Well, again, that's not what the article said in the title, and even the summary says things that are just boldly unscientific, in the sense that it's technically incorrect. They didn't do what they said they did. In this case, the effect of light phase on electrons. So again, I don't know who thought there would be something like this is some kind of new interesting thing, besides their point that they have now somehow isolated it and saw it for real directly. That's their claim. Everybody knew, okay, that the frequency of light had a huge impact on how electrons behave. So that certainly wasn't anything new. What was supposed to be new is they somehow saw it directly, when they didn't see it any more directly than anybody else has ever seen it. So that's just bullshit. Alright. I'll be busy for the next few months. Wow. But I hope to look into other quandaries sometime. I don't know what that is. I might modify this comment. So, okay. I'll be busy for the next few months. That's an interesting line. Okay. As opposed to the past few months. But yeah. Alright, fine. I won't entirely miss you, but you know. That's the way it goes. Alright, so then Puro left a useless comment. Applied mathematics involves carefully chosen approximations. Well, again, that wasn't my argument, that these were carefully chosen approximations, or that they were even legitimate fudge. Yes, of course, there's legitimate fudge, like the small angle approximation or something. It makes the sine the same as the tangent. Or if you put it in radians, you can just use the angle in the math and you don't even have to do any conversions. Yes, that's fine. But that's not what I'm talking about. I'm talking about when they make a claim that isn't true necessarily. That, well, if you multiply this by that and square it, it equals 0. Or something, something a lot more of a structural premise that's built into the formula to basically neutralize a flaw in the formula. Now, and you can't always tell those from, you can't tell the fudgy bits. And that's much like what I'm arguing. As soon as you scratch at some of this stuff, you find crap like that, like the Huygens inconsistency. The inconsistency between how they apply Huygens in the single slit and how they apply Huygens in the double slit. You're not going to see it if you just look at the math. Well, let's see if there's anything else. In all detail cannot be computed well thousands of years of computer time. Again, that's not the argument. The argument, I'm not arguing that some approximations are just fine. Yes, of course they are. The argument is, and I'm certainly for not wasting time computing to the 448th decimal place. Fine, but that's not what they're doing. And certainly none of their math are they actually doing any of these real numbers things. So to even pretend that in most cases they actually are doing the math, no, they're just working the formula. They don't do the math, they just work the formula. But you can make those assumptions sometimes if you know that one number is ridiculously bigger than the other one and the ratio really is practically 0. Well, all of this turns into ratios, and that's what's part of the whole fucking annoying thing in this thing, is that they make this math so ununderstandable. Why don't they just say, look, by using the sign, we're just going to convert the number into a percentage. Instead of, why not just say that? We're converting it into a percentage of 360 degrees. So now we can compare it to this sine theta or something like that. But they don't do the math that way. They just keep it obtuse and as commonly unrecognizable as possible for bullshit reasons. Because their math isn't as good as they say it is. That's the real reason. Sometimes if you know one number is okay, we do that. An example is the approximation possible when you assume the slit mask is far from the detector screen in units of the light's wavelength. Well, again, the light's wavelength is pretty irrelevant to the distance from the slit to the screen, and obviously the distance between the screen and the slit is going to proportionally affect your stated distance of separation. But clearly you could have a difference of millimeters in the screen distance and it's not going to make any difference because there's not going to be a visual difference or even a measurable difference. But clearly if you move it a foot, there will be. And clearly that part isn't the part you need 10 years of computer time to compute, so that part isn't even relevant anyway. No one's asking you to be that precise. So anyways, that's just bullshit. People that do apply math to physics have to learn this. Well, whatever, fuck you. And this is why applied mathematics is a whole different field of math. Well, whatever. There's a point where your formulas are contrivances, not explanations. And I'm going to argue that, especially that on the two-slit experiment on that forum, that's contrivance math. That isn't model math. When you come up with any math, we'll see how you do. It's funny because it won't ever happen. Well, again, you're going to be the guy on the ash heap of jackass history, okay? And I'm going to make sure you're properly labeled for what you are. You're just a shitty rag-talking troll. That's all you are. You're a religious fanatic who's impervious to reason. Period. You don't give a fuck about the truth. You'll never admit a truth. You just say silly jargon to other people to pretend you paid attention. But you're just a fucking tin-foil-hatted asswipe living for your fairy tales. Alright. I mean, really, the honest response is, gee, physics ought to clean up its act. It really is bullshit that they pretend they have nail in the coffin evidence and they don't. That's just bullshit. They shouldn't play a game like that. That's the rational response. But you pussies will never say it because that would violate your God's edict. Always defend the nonsense. Alright, so this is another mindless comment. I don't know if I'm getting kind of tired. So the Dennis Learjet guy says he gets it. He sort of described it correctly, I think. And then mindless wants more explanation. Oh, let me see how much time we got. 50. Yeah, that's enough for now. We'll do that one later. Yeah. It's hot in here. So anyway, yeah, so much to do. So I still got the 2-slit experiment on the porch floor I gotta get back to. And I have a camera now that I can do time exposures. So I definitely want to do the fringes and see how far they extend. Because I have my doubts that they're actually there. You know, that there's actual fringes that keep going. Yeah. So we'll see. Anyway, until next time and such.